This is Bryce Bailey with my Lab 9 video report. Today we're going to be analyzing the motion of a mass on a spring as illustrated by this tracker video here. We can see Dr. Greco grab the spring and let the mass go about in both the X and Y dimensions. The spring oscillates in a nice sinoid wave pattern here. We've taken these X and Y values, put them into a CSV file using Excel, and then we have gone to the Python code from previous weeks and exported the data from that CSV file here. We're then going to use that to have a second ball model the motion of the exact tracker file quantities taken out in comparison to the ball modeled by the code using forces that we calculated in the last lab. As you can see here, the two balls are in nearly perfect unison. We have the X values illustrated by these two lines here, the Y values illustrated by these two lines here, and up here we have the pattern modeling the spring potential energy as the spring goes up and down powered by this mass here. As we can see from the graph modeling here, and also from my calculations using the data that we got from the tracker file, the periods of oscillation for the X values and the Y values are pretty much equal. The motion stays the same throughout both of them, and it's going to make the same pattern at the same rate in both the X value and the Y value. They both come out to be about 1.519 seconds using just simple subtraction from the data we got from the tracker video. Now if we take the spring, earth, and ball all as a system, the only work done on the system is by air resistance, which is for the most part negligible. The spring potential and the kinetic energy cancel each other out, and we are left with a system with very little interaction with outside forces. So what happens if we change the origin? Well, the physics don't change. The recorded values change, but they maintain the same relationship. If we go into our code and change the ball height, which establishing the ball height and the spring position is what gives us our origin, and let's change it to say 200 as opposed to 100. Well, the physics are the same. We have some different values for what our forces will probably end up being, but the relationship between all of them are going to be the same. So changing the origin doesn't really do much. This has been my Lab 9 video presentation. I hope you guys have enjoyed it, and thank you for watching.